Greetings, everyone. Thanks for joining us. This is Eric Andelin, Senior Workflow Specialist at SimActive, and you've joined us for the webinar, How to Meet Photogrammetric Accuracy Standards. And with me, I have Bill Johnson. He's a certified photogrammetrist, certified mapping scientist, and working with DAS Geospatial. Bill, say hi to everybody.
Hello. Good morning, everyone.
Great. Tell us about your role with DAS, your background in photogrammetry.
Okay. I'm the vice president here at DAS. I've been here full-time since 1985, part-time started in 79. It's the only job I've ever had.
Wow.
I don't know if it's a good thing or bad thing, but that is the thing. And I'm kind of the managing supervisor, if you will. I'm over the project management, the production management. I dip my toe into the projects here and there as needed, just kind of overall scope over everything production related or photogrammetry and LiDAR related.
Mm-hmm. So correct me if I'm wrong, you guys own your own aircraft?
We have a helicopter.
Yep.
With a pod medium format camera and LiDAR sensor on that. And of course, several UAVs, and then we partner with folks with fixed wing to do projects literally all over the country. So.
Right. And you mentioned UAVs. You guys got into UAVs when?
Probably the day after they said we could. There was a time people said, when are they going to allow us to use UAVs? And I'm like, oh, they're never going to let us use UAVs. And so when that came up, we started scrambling and said, we gotta dive into this.
Sure.
And so we did.
Sure. Yeah. And to take it a step further back than that, you mentioned that you have a pod system on a helicopter. It has both a medium format and LiDAR. So the medium format camera is?
It's a phase one.
Great. Mm-hmm.
You're going to ask me which letters and numbers, and I get IXU, ABC,
Yeah.
And then the same with it's a Regal LiDAR scanner, same thing. The numbers, letters.
Yeah. Yep.
Elude me.
Yeah. I completely understand. I am probably less than an hour away from the Regal headquarters, so I see them quite a bit. And also...
Oh, is that right?
Yeah. And also the phase one systems, they're very popular these days. So
yeah.
A lot of our customers use the phase ones. Yep.
Yeah, more and more seeing it. You bet.
Yep.
It's been a good co-op connection there, if you will.
Right. So you're a certified photogrammetrist. So am I. My renewal is up, and I've sent in everything. I think you might even have gotten one of the I
did. So be nice to me. I hadn't filled it out yet, Eric.
Exactly. It's a test now. But in the space that we're in, including with our customers here, from SimActive, we not only have the large format mapping companies using our software, which typically do have photogrammetrists involved in the process. We have satellite companies and more so also UAS. And UAS companies, they may be a little bit newer. They may tend to either be operated as a branch or a subset of a survey company, and maybe their knowledge of photogrammetry isn't as robust or as strong as those of us, like you said, who have been working for the same company for the past 30 years.
Forever.
Yeah, we do have a bank of knowledge, and it's nice to share that with people, especially when they're open and they're receiving of what we do as photogrammetrists. So to that end, talk a little bit about, how you got involved in ASPS. You've got a CP and you've got a CMS. So if you could kind of explain the difference to folks as to what those are.
The as far as the CP and the CMS, it's when some of the projects, especially in the governmental side, we're starting to have a requirement for that over the photogrammetric projects for a CP. And so I decided to go after that, take the exam, what have you, and got that. And not long after that, it was probably within a year, we started seeing the same requirement for LiDAR. And so I figured it was just logical to go ahead and just go after that, sit through the exam there, and got the CMS LiDAR. And like I said, primarily just to have those certifications to fulfill that requirement. Yep. for projects.
Yep. I know, obviously, when we do a lot of work with the DOTs and the government, there are requirements in their contracts that are based on ASPRS standards. That's just the way it works here in the States. Knowing
right.
that, this webinar obviously goes out to an international crowd. Every or most countries have their own standards. They're very similar in most cases, but how the roles of a photogrammetrist play within the structure of a mapping company with regulations and so forth may be different. Here in the States, depending on what state you're in, you're required to have a surveyor to sign off on mapping projects. Some states not necessarily so, but we have to keep that in mind. So what we do as photogrammetrists are we provide that additional guidance to the surveyors to help them on the aerial mapping side of things. So just to let the audience know. I'm going to go over the topics real quick. What is an accuracy standard? How a well-accepted accuracy standard such as ASPRS is defined? How does new technology affect accuracy standards? And then how are map products validated against a standard? We'll talk a little bit, right here on what is an accuracy standard. So accuracy standards are basically a set of criteria that define the required level of accuracy for a particular product. This doesn't apply to just mapping. It applies to anything. But it's used to ensure that the results produced, by a system or a process are consistent and reliable and meet required accuracy levels. And then typically they're defined in terms of a numerical value or percentages or some type of statistic that shows that you meet a acceptable level of, error deviation from a desired result. So the key points in there to me, really is consistent and reliable. Because we're doing projects that could be 40 acres, it could be 800 square miles, it could be an entire state, it could be a corridor. So what are your thoughts on consistent and reliable?
Yeah, well, as you said, we want to have this meet the same accuracy standard. We live we being GIS in more of a design level world. That's primarily what we do, is design level accuracy. And so we know if an engineer is going to take what we do and do some preliminary design, it has to meet a very specific accuracy that he can trust if he's going to start doing, dirt quantities and so forth. We have to be within an accuracy that he can trust and verify, because moving dirt is expensive. And so whether it is, like you say, 40 acres, 400, 4,000 acres or more, we have to be able to reliably hand off that final product to an engineer and tell him these products meet the accuracy standard that will allow you to go do your design level. So yeah, consistency in the accuracy, it's just paramount.
Yeah.
regardless of the size of the project, is where those guys are trusting us to hand them something that meets that specific criteria.
Yeah. And, again, in the first point, accuracy standards are a set of criteria that define a required level of accuracy for a particular product. Um, Accuracy standards change based on what the end user is expecting. Um, and
Yeah,
I don't know if you see it, but a lot of times I see people touting accuracies or resolutions that, are extreme and most likely are not necessary to meet the accuracy standards that the end user wants.
right, right.
Yep.
Yeah, we see that all the time. I mean, we go really the polar opposites. You've got some where they're spouting accuracies that either aren't reality, that can't really be achieved, um, or you got the other end of the spectrum. There's still a whole bunch of folks out there that I'm talking about, clients, engineers, surveyors, that don't necessarily know what the accuracies are these days. They're still spouting things that we were saying 20 years ago, plus or minus half the contour interval.
Yep.
Well, 20 years ago, yeah, it was probably the thing. Now we're getting into the tenths of a foot. And that side of the equation, they don't even know that. So we've got to be, here again, use the word consistent,
Yeah.
on letting those folks know we're a lot more accurate than that. But on the flip side, we can't go overboard and tell them, yeah, this is perfect. This is all within a tenth, that kind of thing. We got to let them know what things really are.
Yeah. Yeah. And you're right. At least here, there's still a lot of language out there in contracts, with customers that, maybe date back 10, 15, 20 years. And we can well exceed those, with the technology we have. But
Mhm.
again, it may not be necessary for what they're trying to do. Sometimes we overload our customers with data that they don't necessarily need. Um,
Yeah, it's true.
it bogs them
Very
down.
true.
If you
Yeah,
hand them a mobile
yeah,
lidar based point cloud, maybe they just wanted a surface and they can't even read it.
right.
So,
Right. And that's something, to that end, Eric, that's something we typically ask if they want the full mobile LiDAR, or heck, even the full aerial LiDAR point cloud. We will usually ask them, like, hey, you kind of know how big that's going to be, or is your system set up to do it? Because we can filter it down, we can provide model key points, we can do different things surface just to verify, because there's lots of times they'll get the full point cloud and you hear from a week later and it's like, our computer's choking on it, kind of thing. So we try to talk to them up front and just verify we're all on the same page and
yes.
understanding what they want and really want to do with it, because that's the big thing. A lot of them say, yeah, I want the full point cloud, but they really don't want the full point cloud.
Yep.
So you just
Yep.
got to make sure that.
Let's move on to, how is a well accepted accuracy standard such as ASPRS defined? And the reason I bring this up is because every once in a while these standards get updated, and right now we're going through a process within the ASPRS where update is being considered, and it's being considered because the technology that we have access to, the quality of the cameras, the altitudes that things are being flown, the introduction of LiDAR, all those things have changed the way we look at the accuracy standards, because honestly, again, we can exceed the standards from the previous release while they're reviewing it. So
Mm,
uh, it's really hard to, in a conversation, show what changes there are in those standards. And Bill, I don't know if you've had a really good chance to review those. I've talked to a couple of folks. I've made my comments, but it looks like
mm.
some of the statistical requirements in those accuracy standards may be duplicitous, so they're going to remove, one or more of those, change them a little bit. There's a conversation within the new standards about checkpoints and control. Again,
Mhm.
again, based on how we do AT, how we use our survey, those standards can be either loosened or tightened, depend on the size of the project. So,
Yeah.
uh, it, you know, ultimately, it comes down to, again, what the end user wants, and how that's dictated. Is that dictated by the survey that this whole thing is based off of? um, you know
Mhm.
those are the things that we need to consider. What are your thoughts on how these standards are defined?
Yeah, that's a great question because it's not quite as cut and dry as it has been in the past because you're talking about a large format camera
Mm-hmm.
versus a UAV camera,
Mm-hmm.
two very different things. You're talking about lidar systems that are very high accuracy, not a lot of noise, versus you've got some lower end that do have a lot of noise, and those aren't necessarily creating the same accuracies, but yet sometimes you get that some folks are thinking, well, it's LiDAR, so it must be this accuracy.
Mm-hmm.
But there's that huge disparity. And so to pare that down, be it like ASPRS, I think they need to set the standard, but then we've got to be diligent in saying, okay, we can achieve that with this system, with this sensor, and maybe be open and honest about not being able to achieve it with this system. And two, you mentioned something about the survey. We still tell folks we're we're still dependent upon the survey control that we receive. We can tell you what accuracy we can get that are relative accuracy, but if you want good absolute accuracy, we've got to have very good survey control, and and we can run accuracy reports against that, be it a letter point cloud, be it a 10, to show what the accuracies of the deliverables are relative to that. Where sometimes I think for the most part, we get like the initial ground control, panel control, that'll be either level loops or
Mm-hmm.
very 2 or 3 separate sessions with GPS that are, a minimum of 3 minutes each. And those are good control points. A lot of times what we see is we'll get check shots, maybe some cross section or something like that. And those don't seem to fit as well. And you're like, well, what's the difference? And well, they just did the 7-second topo
Yes.
shot. I'm like, well, time out. That's not the same thing. It's
Yeah.
not the same standard. So you can't, check our LiDAR or our finish 10 um, to that relative to what the initial control is. It's all going to be
Yes.
the same, if you will.
Yes.
So
So,
one of the difficulties I think in redefining the accuracy standards is somewhere in that mix.
yeah, and again, a lot of states were reliant on the surveyors who may not be within our organization, and you're right.
Most aren't. Yeah,
If they
yeah.
go out and run a level loop around a project, then it's really tight. Even if, like you say, they do
Mm-hmm.
multiple sessions with GPS, they can get it really tight. But then if they go out and do the check shots and they're just, bing, bing, bing from point to point to point, um, it may not even be, they may, depending on the project, they may not even be considering whether this is a vertical check shot or a horizontal vertical check shot where you need to be somewhere where you can identify
Right.
that feature. Those create challenges unto themselves on how we define accuracy as far as it goes to our customer. Um, it is a layer cake in that first you start off with the error in the control, then you start off with the error in the solution from your airborne GPS or your AT. And then you
Yeah.
also got to consider that you've got, you went from, a photogrammetric solution or a LiDAR point cloud to a decimated tin. And,
Hmm.
you've opened that up to little amounts of error that have to be considered when you roll all that up to meet your
Yeah.
customers' needs. So,
Yeah.
you know, we'll, this is an open-ended conversation, and we'll close the loop as we get towards the end of it. But let's talk about the technology. How does new technology affect accuracy standards? So, um, yeah, again, you're now using a medium format camera, and a lidar system. Are you capturing in parallel? Are you capturing separately? Is it a night flight and a day flight? You're flying lower, so let's just you talk a
Yeah.
little bit about what technology has done to our business.
Yeah. Well, it's been fantastic, and I could go back, and I'm not going to waste your time. Back when I started in the late '70s, early '80s, everything was manual. It was like, so when I was doing it, it's just I needed, money. So but it was not going to be my career. It
Yeah.
was, I didn't like all the manual part.
Mm-hmm.
But that's, early '80s when computers started coming in. I started wondering, man, is this technology thing? Is it real? Is it going to come into this spectrum that I'm in? And when I found out it totally changed my concept of photogrammetry
Mm-hmm.
to where something just it's a job to now it's kind of a passion. And I love the technology. I love that it's constantly changing. That's what keeps me here. That's what keeps the blood percolating, if you will,
Yeah.
of finding out, okay, with all this new stuff that comes out, what's good, what's not good, how does it apply, what's the best use of it. And it's kind of it's an open-ended question, and I enjoy that part of it. But that's a long-winded way of saying that the technology, especially the LiDAR, has been a game changer for us. When we first used it back, I don't know, early 2000s, we did a LiDAR project and came back and it was at 6 feet off, all over. And I'm like, man, this LiDAR stuff, it's never going to work. Fortunately, that was wrong because now we're getting a LiDAR and we're, on hard surfaces, man, lots of times we're flat, 1/10, stuff like that. I'm not going to, say it's all going to be that way, but that's the results we're seeing. And to me, that's a huge game changer for us. That puts us at another level of accuracy we weren't able to achieve before. And that's what's been fun about it, is being able to see just, how far can we push that envelope to get the what's next? What's the next better, more accurate
Yeah.
system sensor, to give our clients just a little more, little more, little more.
Yeah. Well, you know, it's not wrong to discuss the way this originally started, and we talk about back in the day. It was a calibrated aerial mapping camera that had to go in every 3 years and get recalibrated. You had to meet a certain resolution. And by resolution, we mean how many silver halides are in that frame. The resolution of cameras now far exceeds what we
Oh
had
yeah,
before. And the consistency of it, because we're now
yeah,
not using negatives and diapositives that have stretch in them. We're using, a
right.
solid state CMOS or whatever that is giving us accurate, coordinates. So that's one thing we have to consider. Another is how we do it. So again, you talk about the old method where these were mechanical machines. I mean, they were reconstructing the position of the aircraft as it was taking exposures, and then doing an AT to find that on the ground, where we were literally looking through stereo optics to do that. Um, then the
Mm-hmm.
next step was digital, which is I started in the mechanical world and came into the digital world with those, where we were now putting in plates in a machine that was much more like a tabletop, and it sped things up a bit. You were doing CAD drawing versus hand drawing, on large sheets of mylar.
Praise God for that.
Yeah, you and I are both thankful that that's over with. And like you said, that brought on some really cool technology for us that we could geek out on. Then the next step was digital workstations, where now all of a sudden, whether it's a film camera, well, it is a film camera still, they're being scanned. And those scanned images, now that we have good computing power, allow us to do stereo again. This time, instead of big oculars, we're using glasses that are flickering at the same rate as the camera, as the monitor, and showing us stereo. So you can collect in stereo that way. Then the next step is LiDAR, image-based point clouds, which are the same thing as LiDAR to a degree. But it takes the whole thing into a digital world. Now you just have, like what we do in SimActive, is we create surfaces and mosaics. And from those, you can create products, that meet those type of accuracy standards. So that's the line, or the path that we have taken. And then again, new cameras are way better as far as resolution than the old large format cameras that we used to use. We have cameras now with multiple sensors in there, and we've got combination systems, like you said, that are also running LiDAR at the same time. So that's a lot of technology to swallow when you're considering keeping standards up with the technology. That's a lot.
Right.
That's a lot, and that's why we still see in contracts, it needs to meet the 200 scale or whatever, and we're like, well, scale's different now. I mean, nobody's using a plotted map anymore.
Right.
So that changes things.
But along that line, sometimes with older clients, and when I say older, I say my age. Sometimes I use the old map scale to kind of find out what they want, like pixel resolution. And they're like, I don't know what pixel resolution. And I'm like, okay, let's go back a few years. If I were to put the map on your desk, what scale would that map be?
Yeah.
And they'll say 50 scale or 100 scale. And then I'm like, okay, now I know what pixel resolution you need.
Yeah.
That kind of thing.
You can make the conversion for them, again, to get them what they want. And I do mean to harp on this. Just because we can provide higher fidelity, higher resolution data doesn't mean it's what they need. They're used to working with a certain scale of data or a certain type of data, and their accuracy requirements are for that. So rather than try to push them in the direction of not necessarily more accuracy, but of again a higher fidelity solution, they may not want that. So there is a whole world out there that just does CAD.
Yeah, and that's something that's another good point to bring, because that's something else we try to ascertain when we're talking to, like, I mean, if we're talking about DOT, okay, we know what that standard is and what we got to meet. But if we're talking about an engineer for a development project, for instance, and he may be comparing us against two others, it's sometimes very hard to determine if they say, okay, we want 1 foot contours. Well, now there's 100 different ways to get to 1 foot contours, but those could be very different accuracies. So and if you're trying to get the project, you want to make sure that you're proposing apples to apples with the, company B and C, and you don't always know that. So trying to dig in and find out, okay, you say you want 1 foot contours, to what degree of accuracy, and how do you get there? Because we can do, like you said, we can do an automated approach through SimActive and imagery and generate point cloud. It'd be pretty darn good without really ever touching it manually. But I'm not necessarily going to, 99% of the time, we'll take a step further, and we have our map techs view that point cloud
Mm-hmm.
that was generated. And that even goes with the LiDAR as well. I mean, LiDAR is very good, but we don't just trust it. Hey, it's LiDAR. Here's the Bare Earth LIS just from the programs we run. Here you go. We still set up every project we do, as long as we know what the standards are. I mean, we're viewing the LiDAR point cloud in a 3D stereo environment to make sure that, because your LiDAR is going to be, or your autocorrelated surface through imagery, if there's brush out there, dense grass out there, that's where your last points are going to be.
Yep.
Well, is that the best end product? No, it's not.
Yeah.
And depending on how thick that is, man, there's times you can get into a couple feet worth of things. So we think it's important to view it and have our map techs see, oh yeah, there's some dense stuff there. We need to try to push that down as best we can, or if nothing else, outline it and tell the client, hey, this area, we might not be on the ground. I'd rather be honest with them and say, this area might not be on the actual ground because it's got so much brush or grass or whatever. And unfortunately, I think there's lots of times I go back to the development project against company B and C. They may be just doing the automated approach. You go and here's their cost, where we're taking it the extra step. More man hours, that's more cost, but we lose the project, because it's not apples to apples. So trying to get to that point requires conversation pretty much every project to make sure we're all doing the same thing. And which of those do you want? I mean, lots of times you'll mention that to client. You want the automated point cloud where it could be on top of the brush. Is that sufficient? If it is, okay, we'll write that in with scope and we both understand what it is, and here you go. But if that's not sufficient, let's talk about it, because there's another level of effort to get there.
Yeah. And
so that's something we're trying to be more cognizant of in every project, and not just say, hey, here's the specs, here's the bid or the estimate, hope we get it, kind of thing.
Yeah. Well, you bring up a point there, in that when you're doing these projects, when you're in the initial phase of putting this together, clearly define what the goal is in that document, because as you said, for example, you can provide an automated contour from a point cloud, be it LiDAR or imagery, but honestly, the fidelity of it is so tight that you get a lot of holes, what look like holes, little spikes of elevation that, like you say, may come from brush or anything like that. And honestly, it's not a good looking contour set. And there is an art to this too. And at some point you have to say, is it really important that they even have that? And then, should we strip those out so this whole thing looks better? And that takes time. It's not an automated process. And again, that's extra cost. So when you're comparing yourself to, alternative B, you have to have those things defined. So, and defining that again goes towards accuracy. So, a good point there. So very good point.
Because one more thing along that line, Eric, is if you've got the point cloud, but then you've got a culvert or a drain or any kind of hard break, even though we have all those points, we'll still go and generate a break line.
Yep.
And so we're still doing a decent amount of break lines in the project, so that when you do create the 10 or generate contours, you can actually see exactly where the break is, where it slopes off, what have you. And versus, like I said, if you generate them from the point cloud only, a lot of times, because they're so dense, it's like, oh my gosh, it's not pretty. So how useful is that?
Yep. And to that point, I want to comment this on Correlator 3D. You can there are a lot of things. I mean, correlated 3D will create a surface, will create an ortho, all of that for you. That's great. And you can draw contours from that. And then you can go out and edit those in other software. Or there's other software where you can bring in the surface and the mosaic and you can draw your break lines. And even farther back, you can just say, I'll take the AT solution into a stereo environment like DADEM that you guys use and actually set up stereo models. So there's more than
Right.
one way to skin a cat here. There's more than one way to get to
Yeah.
that solution. And how you as an organization are comfortable with those ways weighs in on how you define accuracy and what your costs are to those customers. So um, there's no one way to do it right, but the way you're doing it has to be defined and it has to meet that level of accuracy. So
Right. Well, and in that regard, Eric, be it a project with a fixed wing aircraft and a large format camera and big sensor, or the helicopter with medium format and a LiDAR sensor, or a UAV, we tell our clients we're going to pick the one that's going to be most cost effective for your project.
mm-hmm.
And we're going to guarantee you that the accuracy at the end of the day that we hand you is going to be the same regardless of which platform
Yeah.
we use. Well, with the UAV, that's a little more difficult because the cameras aren't quite as good as the higher end camera. The LiDAR sensors, tend to be lower end. I'm not going to say low end, but lower end, because you're not going to put a $500,000 LiDAR sensor on a UAV.
Yeah.
People may. I'm not comfortable with that yet.
Yeah.
So you've got what we found. This is a plug for some active, if you will. I'm not getting paid for this, but we looked several years when we first got into UAVs. We were looking at the different softwares out there. Most of them are just the all automated approach, and that's it,
Yeah.
which you can do with some active as well. But the reason we went with some active is because we are able to go through the same format we do with a UAV that we do with the medium format, the large format. We still are doing the AT. We're still checking the AT
Mm-hmm.
the way we normally do. We're still going to a stereo environment to verify that everything's good, be it automated point cloud or whatever. And we did tests with some test projects with your software and a few of the others, couple of others that are pretty popular out there now. And we were going back to my mantra of, we're going to give you the same accuracy regardless of platform. SimActive is the only one that we tried that was getting us there consistently.
Yeah.
The others, when we ran, they may be good where the actual control points are, but then you start checking in between there. It wasn't, it was up, down. It wasn't giving us that consistent accuracy. So like I said, SimActive was for us, it was the only way to go.
Yeah. Well, to that point, a couple of points there. One, you're right. The cameras that are in UAVs are not calibrated mapping cameras by any standard. But Correlator 3D can do the calibration for you. So
right.
If
Which
you
helps.
consider that, yeah, if you consider that
Mhm.
and you include that in how you report to your customer, then it's still a viable option. It still works fine. It's just that in the days of calibrated mapping cameras, you may be able to go, 2-3 years without having to recalibrate, and your solution is still good. Whereas with a camera and a drone, you're probably going to want to calibrate it way more often than that. Just to be confident in the solution, and you can do that. And the reason for that is, again, they're not metric, they're not self-contained and can handle air pressure changes and things like that. So there is flex in that solution, which causes the problem.
And I don't know how much that message is out,
Yeah.
is getting out there. In fact, I don't think it is getting out there of
Yeah.
how important that is
Yeah.
to have that calibration
Yeah.
um, to help you with your accuracies.
Yeah. Well, my second point to that was you need to know a little bit more about mapping to understand that what's being reported, whether it's in our AT report or whether it's in another's, to check, to actually independently go and look at, maybe check shots on the tin or the surface that you've created, just to again validate that nothing's moved around and so forth. So that's
Right.
Again, it goes to,
Well, I think check shots are critical regardless. Yeah.
yeah. So it definitely goes to that. So um, you talked about it in Correlator 3D. We have various tools in our processing workflow to validate. So, again, how are map products validated against a standard? So you've got a standard. We produce a report as part of our AT solution, and it tells you, here the control is, GCPs are XY off, Z off. You can see in that report, honestly, the best part about those reports, whether it's ours or someone else's, it tells you whether or not you've got a good solution or you've got a problem, and you can hunt down that problem. Do not proceed. Don't pass go. If you see a problem there, well, one, does it meet the accuracy requirement, and is it suitable? And two, if there's a problem, you can chase it down by withholding control points, adding other control points, and then you may determine that your problem is not in the AT solution, it may be in the survey.
And that's one thing I like too about the part of the reports, because what I typically look at if we've done the AT through Correlator is just it's the graphic. It's where the green, yellow, or red points. That's a quick, easy thing for me. Just trying to oversee things. Is our solution good? And I love that about it, because you get, there's a couple red points. We need to dig in. We do, like you say, check with the surveyor, or if we have LiDAR, hey, pull out a LiDAR point, see if that helps. But you can't pass go until every one of those dots on that screen are green.
Yeah.
And I really like that. You don't have to be a photogrammetrist to see that they're all green, or whether you got some yellow or red intermixed that have to be fixed.
And there's two things to that. I mean, one, we show you in the bundle adjustment, or not in the bundle adjustment, in the tie points, whether or not the images are lined up or in the right location and things like that, and like you said, a color ramp, green, yellow, and red, based off how many pixels off they are. If you see red ones, there may be an issue with the reported position of that image, anything like it. It may not be necessary. You may be able to say, okay, let's filter out the red ones. We don't need them because we've got enough overlap. So let's take this potential problem out. And then, again, you've got a report on the control. Again, you could look at it, and it's got some color coordination to it, so that's great. But you also, in Correlator 3D, if you go into your AT folder, you've got all the raw data as well. So you can look at the raw data of, your control points and say, there were 8 images that covered that control point, and of those, there were 600 tie points that went across that image. And therefore, it's probably weighted pretty strong versus, there's one on the fringe where there's only 3 images that cover it, and it looks like it might be a little off. That may be why it's off. And going back to being a photogrammetrist, we can look at that and see, okay, you don't throw out the baby with the bathwater. Maybe there's just a quick fix here that you can analyze the solution in.
And usually there is, not always, but usually there is. You just have to dig a little bit to find it sometimes.
True. So, again, you have an accuracy report that we produce. If you're using other software, you have an accuracy report that they produce. So that again is a baseline. Tells you that your AT is good. You're hitting the ground like you should. Next, you're creating a deliverable from that. Whether you went from orientations into DADM, stereo extraction, break lines. From those break lines, you create a surface, and then you're going to meet ASPRS standards or whoever standards you are. You're probably going to put that into some type of spreadsheet and run the calculations to determine, did I meet that accuracy criteria.
Right.
There's a spreadsheet, and I'll show it, but it's really simple. All you do is take in your X, Y, and Z, throw it in there. It's already got what the accuracy standard criteria are, so you could just literally drop it in, and then you could see, hey, did I meet those standards? And it's a very, very simple report to give to your customer that shows, hey, this is all good. So
Right. Right.
and I'm sure everybody's created their own spreadsheet to do this as well, if they want to, but that's just an example, and I'll show it on the screen here. On your guys' end, how do you in the end to your customer show that you meet that accuracy standard?
Yeah, well, we have checks all through the process. Like even when we get the AT report, for instance, and everything looks good, we'll then go have one of our map techs set it up, and they will, using that AT setup, they'll go read the control points. What are they reading that XYZ at? And does that XYZ match the actual control point, or did perhaps the program do a little bit too much adjustment?
Yeah.
From there, we'll run we run the LiDAR against the finished earth. We'll run it against the ground control, provide that report. We'll run it against the check shots, run that report. Then once we get to say the finished 3D DTM file, we'll make a 10, and we'll run that against all those points, because that's really what we're providing the client. The 10 is what they're going to be using. And so we want to show them, hey, here's your control points, here's your check shots based on that 10. So you can feel comfortable in it based upon that. But like I said, it takes the previous checks through the process before we get there to make sure that everything we're doing is flowing through to where we can provide that end report and product to them, that it is truly meeting the standards that they want and that we said we were going to give them.
Yeah. Well, Bill, I think we've covered everything, and rambled on a little bit. I want to thank you for joining me.
Sorry.
I always appreciate it when we've got other photogrammetrists or people that are, deeply knowledgeable about the subject of mapping. Well, Bill, thank you very much. Again, we appreciate it. And we'll talk to you soon. Okay, everybody. So now I've got David Alamillo joining us.
Hey, Eric. Hi, guys. It's good to be back.
So, David, I know you're familiar with what we're talking about here. We're talking about how to meet accuracy standards such as ASPRS, but we're an international business here. There are a lot of other accuracy standards that folks would want to meet, but the basics are kind of there. The things that we can do in Correlated 3D to ensure that you're getting as accurate a product as possible, in our case, starts with AT in general. So, David, can you run us over to the AT section?
Yeah, sure. Absolutely. Let's go ahead and once you open Correlator, you'll find your AT module. Let's go ahead and click that module, and that will load up a series of tools here right on the right-hand side.
We've got some control in here as well. We've got two different codes for those control points. Obviously, a triangle is a GCP, and what looks like a bow tie is a checkpoint. And those, David, can you show them where those are on the list there up in the project directory?
Sure, let's go ahead and expand that section. And yeah, here's where you would find your sections for GCPs and your section for checkpoints.
Right. And just to explain a little bit in correlated 3D, when you open up the AT module, the first thing it's going to want to do is run a quick adjustment so that it brings everything into a localized space. Then the next thing you're going to want to do, if you have control points, is you're going to want to measure those control points. And David, show them where they would load that file.
Sure, let's go ahead and take care of that. Once you're within your AT module, you're going to navigate to this portion of the tool where you'll see it's an import GCP file. It's a second tool here, and we're going to click it. And it's going to ask you to input a text file with your GCPs.
So you can go ahead and close that window. So we've run our bundle adjustment, and again, you can go down to where we have the AT steps. Yep, in the directory tree. You can see we've got an initial 2 to tighten things up, then a step 1 and a step 2 where we measured control. And if you go to just the right of those, you can see the reports that were produced when you ran or when you did those measurements. Go ahead and open that up.
Here we go.
So here's a standard report that we provide. And the things that you need to know are the image tie points. The quality assessment is excellent. The number of tie points per image is 96. That's excellent. Your average projection error is very good. And then next you have just some average information on ground control points, which we'll go into detail further down. But again, it's showing you what your average error and what your RMS error is. It's doing the same for the checkpoints. But understand there's one big difference in Correlated 3D and some of the other software packages out there. When we measure GCPs, the only GCPs we measure and hold to are the ground control points. Checkpoints are allowed to float. They're not part of the solution. So therefore, you can actually treat them as checkpoints. They're not messing with the data set. So that's one thing to be aware of. If you scroll down, David, to the GCP portion of the report, and we'll give it a second to refresh. There we go. Now all of a sudden you can see all the points, the error in X, the error in Y, and the error in Z, and then a combined error. And then also, you know, as far as pixel shift, how far it's off. So you can scroll down through all of them, but you've got all that information. Now, what's more important is all this information is still saved in raw format. So David, can you get to the folders so we can show the people the initial report?
Let's do that. There's a quick link here to open the report folder. That would be the easiest way to navigate to it. Once we do that, it's going to take you to that last step that you guys performed. Yeah. So even though you probably have multiple steps, this is where all that information related to step 2 is stored.
So go up to the original AT summary and open that up. So here we have a very similar report, but it can give you a little bit more information. If you look at average GC residual error, checkpoint error, those are all the same. But if we scroll down and we start looking at, for example, number of images without GCPs, average number of GCPs per image, things like that, you can start looking at your results and make some determinations on, you know, is the error valid? Is that control point worth withholding? Things like that. And again, I think there's even a little bit more to that report. Yeah, there's GCP summary.
Yep. There you go.
So all that information's in there as well. And then we have some more files in that folder that break it down into even more detail.
That's correct. There's specific sections for any of those elements, right? As you mentioned, if we just want to focus on the GCP residuals, we can certainly open that TXT file and let's expand a little bit. It will give you a breakdown of the GCPs, the residuals plus the pixel residuals.
Yeah.
So you not only have that in the PDF report, but also in TXT format if you need to extrapolate any of this information in here.
Yeah. So the point I wanted to make in that is that the user can go ahead and export that information. And let's go ahead. You can close out that window and go back to correlated 3D. And as I said, we're not measuring against the ground when we do this in the AT. So now you've got also surfaces. You've either got a surface that you've brought in. In this case, there's a LiDAR surface. And we also have image-based surfaces that we created here in correlated 3D. The surfaces, as far as the control points go, should fit. I mean, you should see the same elevation below the ground control point that you would, but the checkpoints, again, are allowed to float. So you'll see that, when you run your statistical tests. Because remember, error begins in the survey, it lives in the AT process as well, and then it lives in the surface creation process. Not only that, but also contours. If you're delivering just contours, the package you use to create those contours and how you massage those to make them look better affects your results. David, comments?
Oh, you actually nailed it. That's a lot of the questions we've had. And I'm glad you're summarizing it in the webinar, because I'm going to save the section because there's sometimes a lot of confusion in how that next part of the process goes, and exactly where are those files sometimes located within Correlator, just sometimes even to build their own reports.
Let's turn on the mosaic or turn off the DSM, either one. So here we can see the distribution of GCPs throughout the project. It's probably a little light in the northwest side of things because there's really nothing over there. But in this case, I just went through and took a random assortment of GCPs, converted them to checkpoints, and then ran the solution, not holding those GCPs. Now, if you were really, really looking into this, you might want to run this AT again, flip some of those points, and see that the results are the same. And if they are, you've got a super tight solution. But it's called, checking your data, or if there's a problem, it's called chasing error. And you may be able to do that and isolate out poor control points, or at least control points that were captured in a location that's probably poor for the solution. So that's something to remember. And also, if you look at these, they're color-coded. So even the fact that they're color-coded helps you out. You can see in the lower left corner, there's some suspect issues there. So we like to make it easy for you to see these things within Correlator 3D. So from that, you would create your surface, and then again, you would export your surface out to, whatever tools you were using, and then run your final validation report based on those results. And as I showed before, the NSSDA report, which is a standard one out there, it's nice. It's already got the vertical accuracy requirements for 2-foot contours, 1-foot contours, and half-foot contours under the current ASPRS standards. So you just put in your residual values, and it'll tell you whether or not you've met that accuracy requirement. For myself and David, thanks everybody for joining us. This webinar, as well as all previous webinars and our podcast, can be found on our website, simactive.com, under the Learning tab.